This is the third section of graphs and transformations, and here we're looking at reciprocal graphs. Now, reciprocal graphs, the equation of them comes in two forms. The form y equals k over x and y equals k over x squared. And we're going to look at the cases where k is greater than 0 when it's positive and when k is less than 0 when it's negative. So let's start over here and look at the cases where k is greater than 0, what these graphs look like, and the case where k is less than 0. So when k is greater than 0, so this could be the graph of y equals 1 over x, y equals 2 over x, y equals 3 over x, and so on. It's going to form this shape, like this. Okay, now it's never going to touch the x-axis and the y-axis. And whenever we have a graph that doesn't touch an axis, it gets closer and closer to an axis or closer and closer to a line or a point, but never touches it, we call it an asymptote. Okay, so in this case, the x and y-axes are asymptotes. So that means the graph is getting closer and closer to the x and y axis, but it will never touch the axis and it will never cross it. Okay, so if k is greater than 0, like 1 over x, 2 over x, 3 over x, so on, this is the graph it's going to get. Now, if k is less than 0, so it will be something like negative 1 over x or negative 2 over x, then the graph, the reciprocal graph, is going to look like this. Now, in this graph, again, the x and y axis are asymptotes, and you can see that if I were to reflect this graph in the y axis, I get this graph, and also if you were to start with this graph and reflect it in the x axis, you would get this one. So you can consider this as a reflection of this graph in the x or the y axis. So now let's move on to the graphs which are y equals k over x squared. And again, we're going to consider the cases where k is greater than 0 and when k is less than 0, when k is negative. Now, what happens here, because we've got x squared at the bottom, if k is a positive number, even if x were negative, the whole thing is going to become positive. Yeah, because we're going to be squaring a negative number. So just remember that even if x is negative, y is also always going to be positive. So what happens is that part of the reciprocal graph that was down here at the bottom gets flipped up, because these y values down here, these negative x values here are going to produce positive y values. So it's going to look like this. Okay, so again, this rule about the x and the y axis being asymptotes applies to this graph here, and actually applies to all 4 of these sketches I'm going to draw. And the last one here, what does the reciprocal graph look like when k is less than 0? Well, what's going to happen is if this is negative, even if x is negative, this becomes positive. This whole expression here is always going to be negative. Y is always going to be negative. So we end up with a graph that looks like this. The x and y axis are still asymptotes, and you could consider this graph as a reflection of this graph in the x-axis. Reflect this in the x-axis and you get this graph down here. So let's sketch these graphs here. In part A, on the same axis, we're on the same diagram, we're going to sketch the graph of y equals 4 over x and y equals 12 over x. Now, what happens when you've got these numbers at the top? The bigger those numbers are, the further away the graph moves or appears to move from the axis. It seems to sort of stretch outwards. You'll see what we mean when we go through these examples and we draw these. Okay, so we'll draw the graph of y equals 4 over x, which is generally thinking of it as the graph of y equals k over x. So it's going to be this shape here. Okay. Now the next one, where it's 12 over x, it's the same shape, but what happens is it moves further away. So if I do this in purple, so this is going to be the purple one here, and this one is the blue one here. So the purple one, it basically just moves further away from the axis. Yeah, it is going to have the x and the y axis as asymptote, but remember I'm only drawing a piece of this graph, so we'll just label it so we know which is which. So this here is the graph of y equals 4 over x, and this is the part of the graph which is y equals 12 over x. So the bigger that number is, the further away it is from the axis, okay, so that we can just compare the two. So the second one, we've got the graphs of y equals negative 1 over x and the graph of y equals negative 3 over x. So this is like the graph of y equals k over x, where k is negative, k is less than 0, and the same here. So this one that has the 1 at the top, we're going to draw closer to the axis than this one. This one's going to be drawn a bit further away from the axis. Actually stretches the graph of negative 1 over x in the y direction. So we just need to make sure that we draw the graph of negative 1 over x closer to the axis than the graph of negative 3 over x. So it's going to look like this. Now remember, these are only sketches. What's important is we get the right shape in the right quadrants of our grid. So y equals negative 1 over x here, and this is y equals negative 3 over x. The bigger the number, the further it is from the axis. Okay, the last one, these are like the x squared graphs. Now in both of these, k is positive, so these are going to be the ones where we've got like this reciprocal shape at the top. So this has 4 at the top, so it's going to be closer to the axis than the one that has 10 at the top. So that's just going to be drawn a bit further away, like this. So again, the x and y axis are asymptotes. We'll just label these up. So that's y equals 4 over x squared, and this one is the y equals 10 over x squared. So you should now be able to do exercise 4C on pages 65 to 67. So quick recap. So these are basically the 4 forms of the reciprocal graph, where k is greater than 0, less than 0, and where we have x squared at the bottom. So you need to know these shapes. And what we saw in our examples was that as k increases on these graphs, these are the directions they move in. Okay, so these bits would appear to move away. So anywhere you see this orange, okay, this is what happens as k increases. Or actually, that would be incorrect for the negative k's. So that would be as k is further away from 0. So more negative or more positive, more negative or more positive.